All right, hello. So my name is John Day, and I'm a technical marketing engineer with Cisco Systems, Incorporated, I guess. And I'm going to talk to you about Kubernetes. So ahoy on all that. Real quick, I just wanted to get a real quick question or find out how many people already know everything about Kubernetes, know everything about network services and service load balancer and that kind of frame right now. So quick show of hands just to see, okay, I understand all that kind of stuff. Okay, good. So real quick, I'm just going to go through the agenda with you here. So I'm going to start off with a bit of content about Kubernetes and this whole solution. And then actually, I'm going to start at the end where I'm going to show you the application that we've got running on both an on-prem and an Amazon Elasticsearch, Kubernetes EKS cluster on-prem and then out in the EKS cluster. Show you how this application is able to run on both of these solutions. And then we'll start off again by going to the beginning and actually deploying these solutions through the product that I'm going to talk about here today. And as that product would be deploying, I'm going to tell you about what it takes to be able to take what you normally see if you've done an Amazon EKS deployment, and what does it take for us here at Cisco, on what we've actually done for being able to get you that same kind of experience that you find out on-prem in that solution. And this is really a solution regardless of whether it's CCP or not, but what are the other items that you need around Kubernetes to really make that a very functional product. So after that, we're going to talk about some additional features that we do on premise to actually enhance that capability, make it a little bit easier for developers and operators that are actually using these on-prem Kubernetes systems. And then finally, we'll get back to the demo and we'll actually do that deployment again and show you that same experience that you get when deploying this microservices application on-prem and to the cloud. And then finally, we'll talk about some of the product details. So again, we're here about Kubernetes. So Kubernetes is the platform of choice of the future. Kubernetes itself is an orchestration engine for containers, and it's pretty much become the standard in a lot of the in the new front world because a lot of the cloud providers have offerings for it, and obviously we have an offering for it for mainly an on-prem solution, and also we partner with Amazon in this case to extend that capability for not only out in the cloud, but also on-prem for even those Amazon developers that you may have that are working on this Kubernetes solution. And again, why is it in Kubernetes? Why has it become so good? Because from a developer standpoint, when you start building these microservices architecture, it's much easier to build these applications faster, make them much more portable, and their scalability much easier to scale in this case. And what does this all mean? Because when you come down to it, no longer do you have to build these monolithic applications in a singular kind of language, in this environment space. It's also split out now where you can write these different micro-segmented pieces in different languages you want, whether it be Python, Perl, or Perl, that's a good one, C#, .NET Core, JavaScript or whatnot. So again, we're talking here, the developers here in this case, it makes it very fast for them to be able to do the delivery in this sense, in this environment here. And they can always have that consistent environment because they're packaging everything into this container, and that container is going to run the same in that space that you have. And what a developer really likes in a Kubernetes environment when you use that orchestration platform is you get that same experience, because when you get that kubectl command to issue the commands that you need to get that to run and to work, it's always going to work because you know that for that version it's going to deploy and it's very stable. And it really abstracts a lot of the infrastructure behind it that's needed to be able to get that application to run. So when you know, hey, I have my application, it's going to run, it's going to be pretty simple to deploy elsewhere. So from an operations standpoint, especially in an on-prem scenario, when you look at IT operations on-premise, because Kubernetes is so new and it is the next level, what I call inception into understanding computing, it can be difficult for traditional organizations that just know about bare metal or virtual machines environments, because now these are containers that run at a lower level layer that we see here. So it's difficult, especially when you have a developer who might have been working on a single node cluster on their laptop, to actually put this on a production run, scalable environment where they have to know everything about setting it up, doing upgrades, how are you going to continuously upgrade the solution, the security around it, and how are you going to support it. And what happens when you start getting to other items, when some of the data scientists, or if you do have data scientists, want to start looking into doing AI/ML, how much more energy is going to be required in getting that environment set up to provide for those data scientists to actually run. So again, what does this really get us here in the end is the complexity and cost, because if you do have these solutions and they aren't built on-prem, IT organizations can do this. I'm not saying they can't do it, but at what expense and what cost and what headcount did it take to be able to actually deploy this solution, and how easy was it deployed, documented, and written and supported? What if the lead engineer that architected this leaves for another company? How is that going to be supported in the future for that, for that customer on-prem? And then the bottlenecks, of course, they don't, the developers don't want to wait for these resources to be deployed if they have to have an on-prem resource. So what we're talking about here, and again, I'm obviously with Cisco, so I'm going to talk about Cisco Container Platform, and I'm just going to show you the relationship of what it is that we've done here with Cisco Container Platform to provide that same kind of on-prem solution like we do that you see out in Amazon EKS solutions already. So first off, one of the things that we do is not only do we deploy solutions on-prem, but we also do full deployments of native Amazon EKS clusters from our application itself. So CCP itself is, well, what is it really made of? CCP itself is a Kubernetes application that runs in a Kubernetes cluster that manages other Kubernetes clusters on-prem and in the cloud environment space. And as you can see here, a picture where we have a standard deployment where we orchestrate and architect and deploy and completely destroy the environment that's going to be surrounded in this space. So we're going to go here, and I'm going to switch over to my first demo. All right. So I'm going to click play on here. And so what we've got here is we've got our on-premise solution right now set up. We've got a cluster that's set up running in our Cisco Container Platform. And this is our on-prem solution where it has a master and 3 worker nodes in this case. And you can see here, so we define different pools here, and you can also do a lot of other stuff here. We're talking about adding node pools and upgrades, and I can talk about that later here. Okay? So again, we look at the details just to show you how we have everything set up. We have load balancer IPs and everything gets set up. And one of the items that I do want to talk about here, and I'll show you when we go to the setup, is that we have this set up for access role ARN. And so you'll notice that's for an on-prem cluster, and I'll explain later how you're going to be able to use developers that already have their user accounts that they've already got set up with their key and secret key. Will be able to issue those kubectl commands to an on-prem cluster just like it is with an Amazon EKS cluster already set up. So you can see here, here's our application running. This is the HIP strap that was written a while back. And this is a true microservices demo application that really gives a good example of what a microservices application is. In this case, it's written in several languages, .NET, Go, JavaScript, a couple others I think too as well. But they all have different individualized components, one for shipping, one for recommendations, one for the ordering service, and they all use their communication through that microservices to be able to communicate and talk to each other. So, and again, now you can also see the application that's also running out in Amazon. You can see that by the IP address that you have up there that has been given out from the load balancer, and I'll explain that later here. So there it is. This is the same application that we're talking about deployed to 2 different Kubernetes clusters that are running in the same fashion and giving them that same look, like, and feel experience in this case. And not only is it that, because we're going to talk about what is it going to take to actually get all this stuff to happen and make it work. Okay. So we'll go back to the other slide. All right. Okay, so what I was showing you there in that demonstration was about the IAM authentication. So one of the things that we've done when we've partnered with Amazon in our solution is not only do we want to make it so we can have single pane of glass management for IT organizations to actually deploy Amazon EKS clusters and use their IAM authentication, which is a default standard for EKS, but also give them that ability to extend that IAM authentication to on-prem clusters as well now. So whether or not you're going to do development on-prem and production out in Amazon, or vice versa in this case, or whichever case you chose, that development could still use that same credentials that they've been using already in Amazon for on-prem solutions in this case. So let's go back to our demo here again. And we'll start over and we'll actually talk and walk through the deployment of these clusters in this environment space and kind of show you what happens here. So, okay. So here it is. Right now, so CCP itself runs on top of a VMware cluster. We also have offerings that run in an OpenStack solution provided by Cisco, and we also have future releases coming out on bare metal as well too. But essentially, when we create those clusters on-prem, there's a vSphere that we have a plugin where it has our credential information that gives us the rights and responsibilities that we need to. We're going to ask it essentially the name that we're going to give it, what Kubernetes version do we want to deploy, what CNI plugin, and I'll explain those later here that we've got, and then finally a descriptive term of what you wanted to call the cluster, whose cluster is it, whose cluster is going to have management and offer, be able to use that environment. So next is the screen where we've gone and we've queried the vCenter server, and we're really just asking for landing instructions because, again, we're deploying virtual machine instances that are the Kubernetes nodes in this case, for the master and worker nodes in this case. So again, like I explained here, it's going to just really ask, these are VMware type questions, resource pool, the storage class, the data store, and then what we have is a VM template. And I'll explain that because what happens is VMware, or what we do is we provide through a subscription service, OVA images that are easily uploaded into a VMware environment, and we use that image to clone and create master nodes where we use a cloud init to tell it you're going to be a master, here's your IP address, and then continue on and forward. And I'll explain more of that later. But right now we're talking about our node configuration. So you also have the capability that if you're using PCI pass-through for GPU devices, we can automatically scan and create GPU nodes for the AIML I was talking about. Then here, I'm just setting up a simple master node with a single master node and 3 worker nodes. I'm giving it a CCP username, and then I'm also pulling a public open key that's going to embed itself into each of those nodes. So from an IT or operations perspective, they will have the ability to actually access those nodes to do whatever kind of additional scanning or maybe add additional required operations IT software on top of that. Finally, we have this load balancer IPs, and I'll explain that how we do our IP management in a later section once we've got these clusters deployed. And then finally, we need to pick a pod site or network, and that's what's used for the pod-to-pod communications within this cluster that you set up. So if you have to have a pod that needs to communicate with another pod that's on a different host, that's how that's going to be done. And then finally, down you see here's this root CA certificate, and that's where you have to put in certificates so that if you do need to pull images from a cluster that's not publicly signed, where you have your own self-signed certificates to insert that CA file. But then finally, we're going to get here to our add-on options here, and we have the AWS IAM account ARN role. So what I've done is I've gone out to my AWS account, and I've already created this ARN role, and I've copied it, and I'm going to actually just go ahead and paste it in here. And that is what will be used for our on-prem cluster for that authentication for developers. And in addition, we also have Harbor and Istio, and there's actually other functions that you can install later in newer versions that we've got set up. So finally, you can go ahead and review this, and then you'll be able to click Finish, and then there you go. The cluster will deploy itself out in a rather rapid time. Really depends on how quickly it is to actually clone that tenant image, clone our image that we have and create it and spool those images up. And it's really good because that image is all self-contained. We don't need to have any internet access to be able to deploy anything on-prem. It's fully air-gapped. Everything is self-contained in that image. So where you have areas where you can't have or won't be able to have access to the internet, we can deploy these solutions. So finally here, now we're talking about deploying on an Amazon AWS EKS cluster here. So again, I've already got my permissions set up through my infrastructure provider. And in that infrastructure provider, I've already put in a role that has enough rights for me to be able to create clusters in my my Amazon experience. So I picked my region, the Kubernetes version that I want, the Kubernetes cluster name that I want it to show up in Amazon, or AWS, I should say. Again, we'll pick the instance type. And again, just like the other page, we've gone and we've queried back to Amazon. Well, what are the instance types we can use? And then we also have our full set of image sizes that we need to, our images that we provide because we're running on our Ubuntu image for this case. And then finally, we're going to ask, well, how many worker nodes do you want to run? And then again, it goes and queries back and looks up for that IAM access role. So if you look and you see all the IAM access roles, you'll scroll down and you'll find that Kate's CCP user account, which is what we're going to use for that authentication to be able to get to that cluster. And then finally, again, is that public key. Again, for IT operations administrators, whoever might actually need to get within the node to be able to add or do additional, perhaps, items to that node itself. Then finally, because when we create the EKS cluster, we don't just create an EKS cluster, we create everything. Because not only do we completely create, but we completely destroy the environment. Because that will take everything that's needed. So we create a VPC, all of the subnets, public, private subnets, the internet gateways, the security groups, and everything required to create the network environment, then spool up the master node, and then create the EC2 instances as worker nodes to give you this environment that's all set up. Now, everything you see here is all done in this GUI kind of display, but it really ends up being all API calls. So everything that you see here is really API calls that we have to our backend service that we run. So this can all be fully automated in whatever flavor script of language that you'd like to use here as well. And what's nice is not only do we fully create this environment, but we also completely destroy the environment so that there's no hanging artifacts that are left maybe out in your cloud environment that you'd have running, so that you might get into charged for that you didn't know about. But again, it does the full creation and then full destroy. So let's go back to our slides. All right. So again, let me talk about, well, what does it actually take for us to be able to provide that same kind of solution, that same look and feel that you get on-prem like you have out there in the Amazon EKS environment. So we'll go through here. So Kubernetes is an orchestration engine, yes, and it does all these kind of functions and features to it. But around it, in my opinion, you really need these three other kind of components around it to get you that base functionality that you need. One is load balancing, which is that front end so that you do get your interface and access capability to these environments if you're running a front-end web service here. And then second is network service, where I was talking about where you have that pod-to-pod communication. And then third is persistent storage. So when you do have persistent containers that do need to persist if they do die or have to move to another node, how is that data retained in that environment? So first off, we'll talk about, and this is why I asked the question about the Kubernetes environment, how much did everybody know? So within Kubernetes, when you use Kubernetes, there's different levels of service. And there's the Kubernetes load balancer service. And that is where you get an exposed and external out address that's outside of the cluster that will then route to a front end, whether it be a JavaScript or whatever web service front end, Nginx or whatnot. And so that is the request that's made within a YAML file in Kubernetes. And so when you look here at Amazon, it uses its classic load balancer feature to be able to provision that IP address, and that's what's given to the Kubernetes cluster, and then that is adapted to that Kubernetes service that will then redirect it to the pod that service has been directed to send it to. Now, for us on premise, we have our own full IP management stack that we do. So when we create these, when you set your whole CCP control plane environment setup, we're going to go through a step to ask you, we need a segment of static IP ranges that we're going to use to create our clusters, create IP nodes, master IPs that are not going to change during upgrades. And then we're also going to ask for load balancer IPs. And that was one of the questions that we asked when we created it. And those load balancer IPs can also be assigned after the cluster setup, where it will pull from this IP pool, and that is how that IP pool range is set up and managed to give any operation that when you deploy an application, that ability to then see that same kind of experience. Just like you saw when we first started, how you were able to see that web front end for that hipster app show up on-prem and in the Amazon cloud. So again, just to show you, highlight again, the first thing is that the Amazon load balancer service that's providing that IP address for Kubernetes. We want to ask for that service load balancer. And then down is just showing you the IP pool ranges that you would set up when you're setting up CCP for on-prem deployment of clusters right there. You set up your IP pool ranges, shows you how many IPs are in use. And that, again, that's what we use for everything for deployment of each of the nodes and the master API for each Kubernetes cluster that you deploy, because we are multi-tenant. And then finally, those load balancer IPs. So now the next segment that we're talking about, the lower left triangle here, is the network interface plugin, the CNI plugin. Very standard item here. So within Amazon, it uses its own sourced plugin for CNI called the Amazon VPC CNI plugin. And what it's really done is it's taken it and it's kind of flattened out the network. And I wish I did have a picture for you, but I don't have one for you that was approved. So you can go and find it yourself. But anyway, so this plugin allows you, and it has that, it's a very flat IP space. So when we set up those VPCs with those IP ranges, those are where those IPs are going to pull from those pod addresses itself. So that's how they do pod-to-pod communication. And when we set up an AWS EKS experience, when we spool up each of those worker nodes that we're going to use, they're all put in different AZs. In this case, so that if one does go down, it's going to be able to spawn in a different AZ at this case. So with CCP, we've done it with where we've given customers two different options. So one is the Calico option in this case, and Calico is a very widely accepted CNI plugin in the Kubernetes world here, and we like it because it's very simple to use, and it's very IP over IP traffic is how we've done this, and it also allows developers that write network policy in their Kubernetes clusters the ability to enforce security at that level. Now, when you are taking it, and if you are a Cisco customer or you are looking at Cisco ACI in this fashion, where you have your network fabric or SDN, that not only do we have this plugin that's already set up with CCP, when you deploy in a Cisco ACI fabric, it will also give you the ability where it will create a tenant group and the whole EPG and security groups around that. And what's nice is from a network and security perspective is they will also now, those network and security teams will now even see all of the endpoints, all of those pods exist as routable endpoint IP addresses, and so they can see traffic go from pod to pod rather than if it was running in another kind of VXLAN, hosted VXLAN kind of configuration where the network team can't really see that encrypted type traffic per se. So in this case, it gives them that visibility, and then the network and security team can even apply policies to each of these endpoint groups as necessary in this case. But again, this is a feature that we offer that comes right out of the box if you do have to use, if you do use Cisco equipment. So the third quadrant in this third triangle here that we've got set up here is our storage class environment here. So is the Amazon EKS. So Amazon EKS here, it has its own, when they came out with Kubernetes, already had its built-in plugin, it already had their tree that was set up in the Kubernetes branch itself for doing Amazon Elastic Block Storage. Now coming out with their later versions of EKS, that you'll also be able to use their other CSI drivers, in this case, for whether you can use the EFS or the EBS storage driver in the later versions of Kubernetes. And here, 1 second here, real quick, I have to get some water. All right, and then going on here. So with CCP, what we've done here is, again, we've given you two different choices. So CCP itself is not exclusive entirely to running on top of, it does not have to require to be running on top of a UCS hardware environment. In this current instance that I'm talking to you about, it needs to, it's going to run on a VMware environment. And in this case, it can be a VMware environment that runs on any hardware in this case. And when you do that kind of functionality, we automatically provide the vSphere volume plugin. So when you go and you create a cluster and you use the vSphere volume plugin, it's going to go through that plugin. It will create a VMDK file, and it will attach it to the virtual machine instance that you're running that will go on through and become that persistent storage for that node that's running in that case. Again, with Cisco, we've also taken our other organization that we have with HyperFlex, that's its own hyperconverged infrastructure environment space, and we've taken their plugin and we've also baked that into their environment as well. So now you also have that choice for using their CSI plugin as well, which is going to give you deduplication, and it's iSCSI, and it's much faster as far as terms of actually deploying these persistent volumes because it's a much faster environment. You get the deduplication like I already spoke of, and you also get, we'll have the ability to do replication of that data source as well. So again, we've talked about, that's pretty much the minimum requirements that you need on-prem to get you that same kind of solution. So some of the additional features that we have here at CCP to bolden it up here, or to make it more, to give enhancement to it. Again, we're not changing it, we're just enhancing it because Kubernetes orchestration does not really provide this out of the box. So one of the items that we do have here is a multi-master mode that we use, and we have our own VIP management in this case, again, coming from that IP pool that I spoke of. So it's automatically done. You don't even need to have an external load balancer to run our multi-master mode that we've got in this case. So now when you want to run multi-masters for each of these tenant clusters that you run, that we call, I call them tenant clusters, because you can run multiple Kubernetes clusters in this case. That will give you that high availability, and so you're not going to have any downtime with the master nodes while you're running. So you will be able to issue commands to change the architecture of that cluster if one of the nodes is down. Other item that we also have is a button click that will enable Prometheus and Grafana in this case as well, to give whoever be the developer or the operations team or whatever, direct and very quick, simple insight to it. Now that doesn't mean that this is the only solution for CCP. You can use other monitoring solutions that are out there and available. This is just something that we provide simple out of the box, and we do support from Cisco in itself in this case. So again, it's just a very simple Prometheus and Grafana that you can create and then add in your own templates or dashboards to actually monitor your solutions that are running at that time. Then finally, so if you already have performance, then you also need to have logging. So here's our logging with EFK stack in this case. So there's the Elasticsearch, FluentD, and Kibana, EFK, and that is where we do all the logging and aggregation, and then also showing you the data in the Kibana interface in this case. So again, this is stuff that you can enable or disable as you want if you need it or not. But again, this is stuff that's fully supported from Cisco out of the box, because what we've also added here is our role-based access control. So when we talk about, this can be a single control plane that can manage multiple tenant clusters across multiple on-prem environments. They can have multiple AWS accounts in this environment space here as well. But getting back to the on-prem solution, when you match this up with an Active Directory solution that we have right now, and we have other solutions for authentication coming down the road, this will now give you the ability for, with Active Directory, you can assign groups to certain levels of accesses in these clusters. So this, in the case, will remove the IT from having to then provide kubeconfig files for each of these individuals that need to do development, that they can even go into the front web end of their own environment, log in as the user, be able to see their Kubernetes dashboard if they want, be able to download the kubeconfig file, and be able to issue those commands without having to have direct interaction or waiting for this case. And this, what does this all mean in this scenario? Because what you can do, and I've already explained everything that's already in a full API methodology, that if you already have your own self-service portal, and because we have the APIs, you can have developers or whatnot be able to do their own demand of instances in this case to make those API calls to create that cluster, and then they will be able to get their own Kubernetes, their kubeconfig file to then start working and editing and making their own environment space. They can start coding right off the bat. So you can really minimize a lot of the other functions and features that IT would you'd have to wait for a manual step or process to happen in this case. So we're going to go back to the demo. So now we've gone through here and our application's been deployed. So we'll start up here. Again, we'll go back to the demo. This is the last demo, but we're going to talk here for a while. All right. So now we've got our deployment on-prem, our dev-D deployment, or dev Bravo deployment, I should say. And this is our second cluster that we've deployed on the prem. And again, it was pretty much like the one that we already started with, but showing you what we've got set up. And as you can see, some of the other features that you can have that we've also made it very easy to do is you can add in node pools to this thing. We can do upgrades. And because I've told you everything in this environment that is a subscription, we do continuous delivery with CCP, and it's all self-contained. With that, you take these OVAs, you upgrade your control plane, and now you can upgrade each of these control planes to the newer versions of Kubernetes, even with the applications running. So we allow, rolling updates, live action rolling updates of these Kubernetes clusters that happen in this case. The other item here is this production B, and this is what you can see out here in Amazon in this case here as well. So I've done that also deployment where we've got it out in Amazon, running out in Amazon, and you can see the entire VPC network that's set up. You can also see the EC2 instances that have been set up and running here. And this has all been completely created from the dashboard that we have here now. And that will give you then, the developers, the ability to see all of these environment spaces from a single pane of glass in this case. So we're going through here and we're just downloading the kubeconfig files that we've got set up. And so you can see here, I've got two windows, two split screens set up on the same development computer, my Linux computer that I've got set up here. So I'm just going to go ahead and I'm going to configure my YAML file that I'm going to put into my, I'm just going to change its name. This is an older version. The new name comes down with the proper version names. And then we're going to go to the production B. We're going to download the kubeconfig file from there. And we're going to save it. And I can't remember if I put this in the video, but if you actually looked at the kubeconfig file for the on-prem solution, you're going to see it accessing, or it's going to require the AIM AWS authentication binary, which is going to go out to Amazon, create a token, and then match that token with that on-prem solution in this case. So again, from a developer standpoint, when I issue each of these kubectl commands against these clusters that you're going to see here in the video, this is all using the AWS IAM authentication. Now, I can't show you my authentication because that would be showing you my account, which I'm not going to do actually. So we go through here and we can now see, me typing a long time here. We're going to have our kubeconfig. We're going to export the kubeconfig file here for our dev B. when I get around to typing it properly. There we go. Keep going. So here we go. We're just going to show you, showing you the nodes environments that have been set up here. So those are our on-prem cluster that we've got set up, the master and the 3 worker nodes. And then out here in the cloud, you can see the 3 worker nodes in that case because you don't have control of the worker node that's set up in EKS. So that's where you see those 3 worker nodes. So everything's all set up and running. We can then go through here and we can see that this is the same file, same directory in this case, and we're going to actually do our kubectl apply and apply that microservices application, that hipster app that you saw, to both of these clusters at that time. And you're going to see that same look and feel and how we've done all this environment space that's set up and running. All right, so we've started this one. And you can see these processes will start downloading and spinning up and start running in this case. And you can see that external IP address that's set up. So you can see how we've got it from that IP pool that we've managed through the control plane. And then the same kind of scenario down here and out in Amazon against that EKS cluster. And again, when we did that service load balancer, now it's going to get that external IP address in that case. And so once these services are all up and running, that front end application, that is what you're going to see. That's what the service will then point to for that pod. And once that pod's up and running, then we'll be, actually once all the pods are up and running, as it does do a service check to make sure everything else is running, that you'll be able to go to, and you'll see again that application, that hipster app running itself. So what does this really mean for this standpoint? Now, because this is really how a Kubernetes microservices application should be in this case, then it should be indifferent of where it's going to run and in this environment space, whether it be on-prem or in the cloud, because you've written it so that it can be set up indifferent to that kind of scenario. It doesn't need to, and what's great, because now this is a very easy way to transition and see this. And this isn't only for companies where, even if your company isn't interested in doing microservices at this standpoint, you're going to start seeing third-party applications start to provide this as Kubernetes applications in the future. So this is something, in my opinion, that is really going to start happening and coming down the road here. This is why Kubernetes is a very powerful very powerful application, because it does give you that kind of scope and scalability to be able to make it quite easy for you. All right. So there's the pods all running, and you can see it's just your standard distribution of pods of these applications that are running, and all that communication that happens between all these services that you see running, the ad service, cart, checkout, currency, email service. They're all spread across, and they're all communicating with each other in this application, this microservices application. Okay? So we'll finally get back here to the other part here. So let's talk about Cisco Container Platform. So again, this is how we've done this environment to get you the Cisco Container Platform on-prem. It's a very turnkey solution. So what did we do? We took all of the open source projects that are out there, like I said, the Grafana, the EFK stack, all the plugins that are out there from, all the plugins like Calico, and we put these all into, and now we sell this as an enterprise supported product in this case. So everything that you see here, this is in through a subscription environment here. So everything that we sell in this environment is a supported product. So for companies that really want to look for something that's very open source, and they want to have to do stuff on-prem because they either can or won't be able to go to the cloud, this is the offering that we're able to provide to customers, and a very sensible kind of solution. So again, you get that self-service. We continuously deliver a new deployment here where in every 30 to 45 days a new version comes out that gives you that ability so you can stay current with the newer versions of Kubernetes as they come out. Also has all the full-on bug fixes and features that come with this case. We're fully backed even in the back end, so even with the hardest problems that we might have with Kubernetes, we're backed by Google in that sense, and we run everything on Ubuntu, and it's fully backed up by Canonical in that sense as well. But again, if there's any problems, you run this. If you run this on a hyperflex kind of a environment, you can think of this as a whole stack of applications, but now you can think of this as an appliance, because everything is a single throat to choke to call Cisco if there is any issue, but everything is backed up and managed by, in this case, a Cisco environment space. So again, it's native EKS cluster. I mean, it interacts natively with EKS. We're 100% upstream native in our Kubernetes solution and source, so we don't change anything. So if you have Helm charts that you know deploy on your known version of Kubernetes, it's going to deploy and work on our environment space. Again, everything that when we deploy, we have to go through our own Cisco CSDL, which is our own security group, so we cannot actively deploy anything that hasn't gone through, that has any open issues with them, or I can't remember the word right off the bat. We do all the updates, we do all the security, so everything is really well taken and managed of in the solution. So we've really made it a lot easier for these IT and operations teams to be able to provide Kubernetes clusters on-prem at a very attractive price, in my opinion. And then, I'm sorry, I got to talk about the IML. So one of the other features that we do have in this case is when you do build clusters, whether or not you have GPUs or not, and you want to start looking at IML, we have also a turnkey feature that will install a full Kubeflow environment here as well in any of the clusters that you deploy. So again, the product details here is, again, we've made it very easy from a security, DevOps, and our ability to provide this open source solution that is fully supported from Cisco. You know, the subscriptions, it's 1, 3, or 5 years. It's also sold by partners, and we support that whole thing end to end. So really, this is a full-blown open source solution that you can get without having to worry about getting stuck with, well, how is this going to be helped? How am I going to get this debugged? How am I going to be able to get my stuff running in production if something happens or something goes wrong? And again, so this is really the end of here on this conversation. I can take questions here in a second. If you do have other questions or you want to ask me more detailed questions, I will be down at the booth over there at the Expo Center in the Venetian, booth 2220. You'll be able to see it quite easily. There's raining blue lights above us in that kind of case and scenario. I'd be more than happy to talk to anybody that has any, one-on-one questions in this case. Since we do have a lot of time, because I talk very quickly apparently, are there any questions out that the audience may have real quick that I can take? I'll go with you first. The question is, do I have a dashboard that shows the multiple clusters? So I do have an overall dashboard that will show you where you'll have tabs that will show you here's your on-prem clusters, here's your deployed clusters in Amazon, in that kind of scenario. So yes, we do have that. But it won't show you, it will show you what the resources and where they've deployed, and it will give you links that will click you directly. So if you have an EKS cluster, it will give you the link to click you into that EKS cluster in Amazon. We don't have anything that shows you like exact CPU percentage of usage. We do direct you to the dashboard directly. So we run a Kubernetes dashboard if you wanted in each of those tenant clusters if you care to. So. Right. Well, it's different in the case that, it does have a lot of similarities to it. One of the aspects that we have is, again, this is from a Cisco. It's a fully enterprise supported kind of solution. A lot of things are similar. And also, if you are a Cisco customer per se, we already have a lot of these products already integrated that we worked with our other product groups to have that integrated into that solution. And we continue to provide customers not only, like I said, not only to be able to run this on VMware, but in OpenStack, and coming out pretty soon is a bare metal environment as well too. So that's what we have coming down the pipe. So we have the ability for, if you want to get off of having to pay hypervisor tax in this environment space, we do have some other stuff coming out down the road, and that's our journey that we're doing here with CCP in this kind of case. I'm going to get to you because he raised his hand up next. So go ahead. Yes. No, we don't really do that, and that would kind of get against, in my opinion, some of the grain of how a Kubernetes cluster should run. If you really were going to do something like that, you would still run 2 different clusters, and in this case, if you wanted to run like this hipster app and you wanted to have high availability, this is where you'd want to use Istio for a service profile, for doing service mesh in that case, so that you could send traffic to either on-prem or out in the cloud in that kind of environment space. Mm-hmm. Yeah, if you do the Istio service load balancer, you could tell, hey, if it comes into this ingress port, you can send 60% of your traffic to on-prem, and then you can also have it point to another service that's running out in the cloud. So that's an Istio kind of feature. So that would, honestly, in my opinion, that would be the better way to be able to do that kind of functionality in that case. Go ahead, your question, sir? Yes.
And I see all the Cisco Container Platform. How do you compare? I'm not sure if you're familiar with OpenShift.
Yes.
Okay, good. How do you compare yourself to OpenShift functionality limitation? Because a lot of, for example, Google Containers has a lot of less limits and pods and all that to what Apple is providing. And so I'll leave the question open to you. How do you compare functionality-wise to OpenShift as a platform, and how do you compare price-wise, because there's also...
Right, so how do we compete with OpenShift from a platform perspective and then from a price-wise perspective? So typically, we really like to think of OpenShift as a platform as a service in this kind of scenario because it has that platform capability, and it is a bit of a modified it is a bit of a modified Kubernetes environment, where what we've really done is we've really taken what the cloud provides in that kind of scenario, and we provide that on-prem in that same scenario because you get the same kubeconfig file, you're going to be the administrator in that kind of case. What we do is we don't have a limitation per se on, again, OpenShift has its, again, a very restrictive, it uses its OC commands.
So there is two limitations. There is the node limitation itself, and you're based on the Google model.
Well, yeah, we're based off the full upstream version of Kubernetes. So whatever the limitations that we have in that current release of Kubernetes is the limitations that we adhere to in that kind of scenario.
So I'll focus you more to actually, if I'm using your SDN, because I asked this question on
Okay.
where you be able to provide, I know you brushed on it a little, you'd be able to provide multi-tenancy and restriction using Cisco SDN. Would that implement your current cluster and would be able to provide a true platform that can provide true multi-tenancy that can pass PCI compliant? Because most of Kubernetes clusters are not multi-tenancy. Basically, you just have to run them as they do. And the reason I actually can use it is because you call it a platform. So I want to see, like, it's not a cluster, it's a platform. A platform can provide multiple services over the Kubernetes cluster.
Yeah, so again, we provide that basic Kubernetes cluster in the sense where it also has like that load balancing, the networking that we have that comes with it. And then we do have other features that are on top of it from a platform perspective, from the logging and monitoring. I'm sorry?
I'll come and talk to you.
Yeah, please, I'll come to me after that. And then the other thing about the pricing is that we are very aggressively priced compared to OpenShift, I'm sorry. Yep. Any other questions in this environment here? Yes, go ahead, sir. So we do have a procedure for backing it up. We don't have an automated click backup thing in our current scenario. I'm sorry? Well, there's a procedure that you'd have to have, but we do have a full backup and restore capability that will get you the metadata to recreate your clusters if there is. So we have our master control plane that runs, and we do have a full backup procedure for that. So in the event that that does happen, it will be able to, you create a new one, you restore from that, and that will be able to see all of the tenant clusters that we have in that kind of scenario. Yes, we do have a container registry on-premise as well. So in one of the solutions in the slides, we can spool up a harbor registry right off the bat that can run on that cluster that you can use for that environment. Now, what we typically recommend is running one of the clusters as just a harbor registry because it really gets down to self-signed certificates. In this scenario, when we get down to another road of development, we'll have the ability where you can provide your own certificate. In that case, when we have the ability to tag, IP addresses to each of those kind of scenarios. Does that answer your question? Good. Other questions? Yes, go ahead again.
So I saw the storage class mentioned you were using vSphere plugin.
Yes.
And I know that does not support multi-rewrite.
Correct. Yeah, so we don't, so again, that's just something, we don't have that is supported from our environment. So again, the one thing I do want to kind of stress on the point is that this is an enterprise-supported kind of solution, so we have to really take our steps and watch through everything that we have because we can actually support this at an enterprise open source kind of solution. So right now, I don't think we have any kind of plugin that will give you that multiple read-write solution. I mean, there's nothing stopping you from adding in like the NFS plugin post-haste. Again, nothing that we provide here stops you from doing any other kind of environment. You can put in any of the other CSI, CNI plugins that you want on top of a deployed cluster. Just at the endpoint, we won't be able to support that from a TAC position kind of scenario. So if you do have a read-write and then you have some kind of write issue with a persistent pod, unfortunately, we can try to help you, but ultimately we won't be able to support that kind of scenario because, again, we're trying to support to an enterprise-grade scenario for that full-stack solution. No, we also have the Cisco ACI plugin if you are using the ACI. So right now, honestly, we don't see enough of a drive to really see the support of a Windows solution in this case. We do have it on the roadmap. I mean, yes, we can do it, but again, it's more of a licensing and a engineering effort to be able to configure that, to be able to put in like a virtual, if we do it, it would be like a virtual kubelet kind of format, and that's just something that there's just not enough demand for in that kind of scenario. Correct. Yeah, no, that would be something that, you know, I've only have one customer that's ever asked for it, to tell you the truth, so that's the only issue I have. Again, back to you, sir.
Yeah, so do you have a plan for supporting other storage modules like CIS and EFS and all that? Because that's crucial.
Yes, so we do have a plan for that, and the bigger question, especially when we're talking about working in enterprise environments, is actually qualifying, getting qualified with some of the bigger storage vendors with their plugins as well. So that's currently underway, and so that will be something that will be a certified solution that we're going to come down the road. The other ones like NFS, well, who's going to, do we want to take on the full, Ceph plug-in support for that, versus when we talk about SAN storage providers that do have their big SAN storage networks that want to be able to use persistent volumes for customers. Where again, we're talking about enterprise customers that already have their big storage solutions out there that, hey, they want to use their plug-in already. So that would be our biggest qualification at that standpoint right now. So anybody else? Anybody left else here to ask me a question? All right. I guess that's it. Well, thank you very much. I appreciate your time.